Hello everyone. In this video we'll study inverse trigonometric functions. The inverse trigonometric functions play an important role in calculus for they serve to define many integrals. The concepts of inverse trigonometric function is also used in science and engineering. In chapter 1, we have studied that inverse of a function f denoted by f power minus 1 exists if f is 1 1 and onto. There are many functions which are not 1 1 onto or both, hence we cannot talk of their inverse. In class 11th, we have studied that trigonometric functions are not 1 1 and onto over their natural domain and ranges, and hence their inverse do not exist. In this chapter, we shall study about the restriction of domains and ranges of trigonometric functions which ensure the existence of their inverse and observe their behavior through graphical representation. In class 11th, we have studied trigonometric functions sine, cos, tan, cotangent, secant, cosecant, etc. And we have discussed about their domains and ranges also. In class 11th, we have studied how to make graph of sine. Like you can see here, y equal to sine x. Here you will put different angles and you will get different values of y, and you will write it on the graph x and y in the way, and you will get this kind of graph for sine. Now we'll make graph of sine inverse x. But you know it is not possible as function sin x is not 1 1 onto. So what to do? We will restrict its domain minus pi by 2 to pi by 2, and then we can make graph of sine inverse x. We will make graph of cos in the same fashion as we made graph of sine x. Similarly, if we interchange the position of x and y, we will get the graph of cos inverse x. Similar way to restrict the domain 0 to pi. Just we have to remember one thing, this time domain will be 0 to pi. Similarly, we will make graph of 10x. Like you can see here, y equal to 10x graph is already there, and as we have made graph of 10x, similarly we can make graph of tan inverse x. We just have to interchange the position of x-axis and y-axis. The following table gives the inverse trigonometric function principal value branches along with their domains and ranges. Here you can see sine inverse domain is minus 1 to 1 and range is minus pi by 2 to plus pi by 2. Similarly, cos inverse domain is minus 1 to 1 and range will be 0 to pi. Now see tan inverse domain is real number and range is open bracket minus pi by 2 to pi by 2. Now students, we will do question from NCERT exercise 2.1. You can pause the video and you can see the questions. Now we will solve question number 1. Find the principal value of sine inverse minus 1 by 2. Let sine inverse minus 1 by 2 is equal to y. We have to do in each question like this. Whatever is given, just assume it equal to y. Then if we transfer sine inverse other side, it will be sine y. So sine y is equals to minus 1 by 2. We know value of 1 by 2 in term of sine is sine pi by 6. And if we take minus inside the bracket, it will be sine minus pi by 6. Now we know one thing, that range of principal value branch of sine inverse is minus pi by 2 to plus pi by 2. And sine minus pi by 6 is equals to minus 1 by 2. Therefore, the principal value of sine inverse minus 1 by 2 is minus pi by 6. Now we'll solve question number 2. Find the principal value of cos inverse root 3 by 2. Let cos inverse root 3 by 2 is y, and it will transfer the cos other side, will be getting cos y is equals to root 3 by 2. So cos pi by 6, we know the value is root 3 by 2. So we know another thing, that the principal value branch of cos inverse is 0 to pi, and cos pi by 6 is equals to root 3 by 2. So principal value of cos inverse root 3 by 2 is pi by 6. Again, find the principal value of cosec inverse 2. Let cosec inverse 2 is equals to pi y, then cosec y is equals to 2, and value of cosec pi by 6 is also equal to 2. So we can equate this. Now we know the range of principal value branch of cosec inverse is minus pi by 2 comma pi by 2 minus 0. Therefore the principal value of cosec inverse 2 is pi by 6. Now question number 4. Find the principal value of tan inverse minus root 3. Let again tan inverse minus root 3 equal to pi. Then tan y will be equals to minus root 3, and root 3 is 10 pi by 3, so we can replace the value. If we take this minus inside, we'll be getting 10 minus pi by 3. We know the range of principal value branch of tan inverse is again minus pi by 2 comma pi by 2 open bracket, and 10 minus pi by 3 is minus root 3. So we can say that principal value of tan inverse root 3 is minus pi by 3, as it lies in this interval minus pi by 2 to pi by 2. Now question number 5. Find the principal value of cos inverse minus 1 by 2. We know in the same way, cos inverse minus 1 by 2 equals to y, then cos y is equals to minus 1 by 2. Minus cos theta is equals to cos phi minus theta. From the above formula, we can write cos pi minus pi by 3, then cos 2 pi by 3 after solving pi minus pi by 3. We know the range of principal value branch of cos inverse is 0 to pi, and cos 2 pi by 3 equals to minus 1 by 2. Therefore the principal value of cos inverse minus 1 by 2 will be 2 pi by 3. Now question number 6. Find the principal value of tan inverse minus 1. Tan inverse y will be equals to minus 1, and minus 10 pi by 4 is equals to 10 minus pi by 4 by using the formula. We know the range of principal value branch of tan inverse is minus pi by 2 to pi by 2 open bracket. So 10 minus pi by 4 will be equals to minus 1. Therefore tan inverse minus 1 is minus pi by 4. Now question number 7. Find the principal value of sec inverse 2 by root 3. We'll assume again the question as y, then sec y will be equal to 2 by root 3, and 2 by root 3 in sec term is sec pi by 6. We know the range of principal value branch of sec inverse is 0 to pi close bracket minus pi by 2, and sec pi by 6 is equals to 2 by root 3, we know earlier. Therefore the principal value of sec inverse 2 by root 3 is pi by 6, as it lies in the given principal value branch. Question number 8 says, find the principal value of cot inverse root 3. Let cot inverse root 3y and cot y will be equal to root 3, and cot pi by 6 is equals to root 3. We know the range of principal value branch of cot inverse is 0 to pi, and cos pi by 6 equal to root 3. Therefore the principal value of cot inverse root 3 is pi by 6, as pi by 6 lies in the range. Question number 9 says, find the principal value of cos inverse minus 1 by root 2. Again in the same way, assume the question as y, cos y is equals to minus 1 by root 2. Then 1 by root 2 we know it is cos pi by 4, it is written there, and we can write cos as cos pi minus pi by 4, cos 3 pi by 4 after solving pi minus pi by 4. We know the range of principal value branch of cos inverse is 0 to pi, and cos 3 pi by 4 is equals to minus 1 by root 2 is 3 pi by 4, as 3 pi by 4 lies in the interval 0 to pi. So this is the required value. Now question number 10 says find the principal value of cosec inverse minus root 2. Let question equal to y, then cosec y is equals to minus root 2. Root 2 is cosec pi by 4. If you take this minus inside, it will be cosec minus pi by 4. According to the trigonometry, we are allowed to do this. We know that the range of principal value branch of cosec inverse is minus pi by 2 to pi by 2 minus 0, and cosec minus pi by 4 is equals to minus root 2. Therefore, the principal value of cosec inverse minus root 2 is minus pi by 4, as minus pi by 4 lies in the given interval of cosec inverse.